everyone, good day. So once again, this is your teacher friendlies and we're back for the second topic for our MELT 2 module of the third quarter, which has the title of Solving Problems Involving Permutation. So last time we have discussed about permutation, its meaning, its definition, and as well as the fundamental counting principle, which is the basic technique that you must master in order for you to apply this or understand better about permutation, and as well as the three common methods to illustrate permutations. So let's start first with the meaning of permutation. So let's have a short recap. So once again, what is permutation? So permutation is the arrangement of objects wherein the order or position is important. So those are the two words that you must remember if you are arranging a set of objects, and wherein the position or order is important, then you are applying permutation. So I started my lesson by giving you an activity that would help you develop. This is what we called as the fundamental counting principle, which is very important. So what does fundamental counting principle means? In the fundamental counting principle, it says there that if there are p ways to do one thing and there are q ways to do another thing, that means there are p times q ways to do both things. So p and q stands for the number of ways wherein you can do one thing, and another thing are the possible ways wherein you can do another thing. And if you combine both, you get the product of both, so you are getting the combination or the possible ways wherein you can do both things. Not a combination, because combination is a different topic. So we will be dealing with arrangement of object that has position or order is important. Then we have listed all three methods with examples. Last time we have discussed about listing method, tree diagram, and as well as formula for permutation. By the way, listing method and tree diagram can only be used or applicable if we have a fewer number of objects in a set, because the number of objects in the set, the less number of possible ways. So let's say, for example, if your total number of possible ways that you can do, or total number of possible ways or permutation says more than 100, so it will take a very long time to finish or list down all of the possible ways using the listing method and the tree diagram. So that will lead you to the third formula or the third method, which is using the formula of permutation, which is p is equal to n factorial over n minus r factorial. So I will be discussing what does those two letters means and why did we say factorial, where did it come from. I will explain it for you. Alright, so please join me in my short discussion. So this is all about what you were waiting for. We will be dealing with the four formulas in solving permutation. I will be giving examples not just from your module, but another example that will help you see it clearly why or how the answers were actually derived from the given. Alright, so let's get the ball rolling. Alright, now let's start with the first formula of permutation. Permutation of objects taken all at a time. Let's say, for example, this is for the number one formula. Let's say, for example, in our problem, in how many ways can you arrange the letters from the word kind? So the example on your module there, you were asked, or you were given with the word kind, and you were asked to arrange these letters all at a time. So wala kasang maibilin na letter. All of it will be included for the sample ways. So you would like to, let's start first. How can we arrange this one? Our formula is P n. Your n is the total number of objects in a set. Since we are using the word kind as our given, in the word kind we have 4 letters in it. So the number of objects that we have is also 4. And that stands for your n. And your r, since you will be taking all the letters all at the same time, so sa ron tunis na 4 na letters, we will still represent that one with the small letter n to indicate that we will be taking the same number of objects or same total number of objects in a set, which would be equal to n factorial, which is very easy. So using the word kind, let's start with by drawing 4 spaces here. So if you can see, if we start with the first letter K, the first letter K, it can be positioned on any of these 4 spaces, right? You can put K here on the first position, or you on the second, or on the third, or on the fourth. So that means to say that the letter K has 4 possible options to choose from. So let's put here 4 to indicate that the letter K can be positioned in 4 ways. Alright, the next letter is I. Okay, same thing with I. Since there are only 3 spaces left, because we have already positioned the first letter, which is K, the letter I can be positioned on any of these 3 spaces. So it has 3 possible ways that you can arrange I. Let's put here 3 to indicate that there are 3 possible ways you can arrange the letter I. Then we have 2 remaining letters, which are N and D. So let's go with the third letter, which is N. Since you only have 2 spaces left here vacant, the letter N can be positioned in 2 different ways. You can put an N here or to the last. Alright, so that means there are only 2 possible options for the N to be positioned on these remaining 2 spaces. Then what will be left is the letter D. The letter D, since it is the last letter, it doesn't have a choice, so it has to be positioned here at the last one. So it only has 1 possible way, so that's why we have here 1. So if you can see, this is how we get the factorial. Since the number of letters in the word kind are 4, your n is equal to 4. And since the formula is P, n, which is the total number of objects in a set, which are the 4 letters in the word kind, and your n, another n, is taking the same number of letters. Wala tasang may gunwigit na letters. We are taking all of it. So that's why it has the same letter n here. N is equal to n factorial, which is if we are going to expand 4 factorial, we would have this. So let's solve. It's just easy. 4 factorial, your is equal to 4, and your P, taking all objects all at the same time, is equal to n factorial is equal to 4 factorial, depending on our given, which is 4 times 3 times 2 times 1. So to write this one, to shorten this formula or this expression of 4 times 3 times 2 times 1, we use the 4 factorial. So 4 times 3 is 12, 12 times 2 is 24, times 1 still 24. So you have 24 ways. Alright, now let's proceed to the second formula. Permutation of objects n taken r at a time. So this is very familiar to you because you are able to use this one upon solving or illustrating permutation using the formula during your Mach 1 module. So once again, the formula for that one is P, wherein n is the total number of your objects, r is the total number of objects that you would like to take at the time. So it's not all, would be equal to n factorial over n minus r factorial. So let's apply this formula to our given problem. The problem on your module says if you were given a numbers 3, 4, 5, 6, and 7. In how many ways can you arrange two-digit numbers out of this given numbers 3, 4, 5, 6, 7? So basically, from the question itself, if you try to repeat the question in how many two-digit numbers can be formed out of the numbers 3, 4, 5, 6, 7. So you are not going to take all of these 5 digits all at a time, because you are being asked to take only 2 at a time. So it can either be 3 and 4, 5 and 6, or 6 and 7, but we have to solve it properly by applying the formula for permutation and wherein n objects taken are at a time. So let's apply the formula to the given problem. The number of your objects in a set are 5 because of 5 digits. So we have 5 factorial over your n still 5. So that will be 5 minus your r, which will be taking only 2. So r is equal to 2 minus 2. And take note, this is still in factorial. Alright, so what happened there was your 5 factorial. If we are going to expand this, that will be 5 times 4 times 3 times 2 times 1 over 5 minus 2 is 3. That will be 3 times 2, or 3 factorial, 3 times 2 times 1. So as you can see here, numerator has this factors 3, 2, and 1. Same with denominator 3, 2, and 1. So you can cross this out. What will be left are 5s and 4, or 5 and 4. So that will be 5 times 4 is equal to 20. That means the number of possible two-digit numbers that can be formed out of this 3, 4, 5, 6, 7 will be 20 ways. Now let's use another example, a very common one. You and your friends, so barkada ka mo, and in your group you're all 7. So, pito ka mo kabilang na magbalarkada. You want to take a selfie, or I mean the goofy or class picture, but you would like to take a couple of pictures, 3 at a time. So, tatlo lang ka mo sa kada photos, and you would like to explore in how many possible ways that you can arrange yourself 3 at a time when you are all 7. So, let's name those members as A. Let's say these are your initials, A, B, C, D, E, F, G. So, there are 7. So, these letters A, B, C, D, E, F, G represents the initials of the 7 people in a group. So, you would like to arrange yourselves for a class picture, taking only 3 of you at a time. So, your N is 7, while your R is 3. Substituting on the formula, you have your P, still take an R at a time. N factorial is 7 factorial minus 7 minus 3. That's 7 minus 3, so you can see. That will be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 3 is 4 factorial. That's 4 times 3 times 2 times 1. So as you can see, same method that we did on the first example. We have 4, 3, 2, 1 factor on the. So what happened there was the factor 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. We just crash out the factors 4, 3, 2, 1 because we both have that on the denominator and as well as on the numerator. So what was left are 7 times 6 times 5, which gives us 210 ways. Now let's proceed to the third formula, which says permutation of objects which are distinguishable. What does it mean when what does it mean of the word distinguishable? So what is another term for distinguishable is distinct or recognizable. And why it is being asked, why it was emphasized as distinguishable. So diri na masulod ang aton nga repeated figures. So depending on the given your repeated figures, it can be in the form of a letter. If your set of objects are composed of letters, or it can be numbers if the set of objects are composed of all numbers. So once nga may are repeated figures inside the group or in a group, you have to find out the permutation of those distinguishable objects. It's just like in the word mom. You wanted to find out in how many ways can you arrange these letters from the word mom. So you can see you have two letters that are being repeated. So hindi mo siya ma-recognize yung isa ka M with another one. So hindi mo siya balaan kung ang muna siya balang first letter or ang last letter, not unless i-write mo ang second M as small letter M, so you can make your combinations. So that's why they just added this word distinguishable, because we will only need to find out the number of permutations of those distinguishable objects. So our formula for that one is P is equal to N factorial over P factorial Q factorial times R factorial. Now in this formula, it doesn't have to be this three characters down at the bottom, because P, Q, and R representing those characters or figures that are being repeated. So if there are only two letters or numbers that are being repeated, then you can have P factorial or Q factorial. It's just being represented in the form of variable because this is a formula. So let's say for example there in your module you are given the word mathematics. So as you can see in the word mathematics, there are several letters that are being repeated. So the word mathematics composed of 11 letters, so your N automatically is 11. While your P, Q, R, let's try to find out what are those letters that are repeated. First one is letter M, repeated twice, and you have to take note of the frequency because that's the number that you will be substituting onto these letters here. So your M repeated twice. And what's another letter? Letter A repeated twice. What else? Letter T repeated twice. So take note of this frequency. So this frequency 222 will be substituted to these three letters P, Q, and R. So that's why I have said if there are only two characters that are being repeated, so that will be N factorial over P factorial times Q factorial. So applying it in the formula so you will know why or how the answer has been derived. So that will be P, your N factorial, you already know that this one composed of 11 letters. So you will have 11 times 10 times 9 times 8 7 times 6 times 5 times 4 times 3 times 2 times 1. That's for the 11 factorial when expanded. Your P, those are the M's that are being represented or repeated twice, so that will be 2 factorial. Your Q is also represented by letter A, which are repeated twice, so that's why it's 2 factorial. Same with your R. I'll remove this parenthesis. So that's R factorial. I mean 2 factorial. So expanding 2 factorial by 2 factorial by 2 factorial, you know that 2 factorial is 2 times 1. So I'll put a parenthesis here. 2 times 1, that's for the first 2 factorial, times another 2 factorial, which is 2 times 1 as well, and the third one, which is your R, 2 factorial 2 times 1. There you have it. Okay, now try to look at this statement. P is equal to... Alright, now let's continue on the third formula wherein you are being asked on how many distinguishable permutations can be made from the word mathematics. So let's continue. We would have 11 factorial over 2 factorial times 2 factorial times 2 factorial, which are the frequency of the 3 letters that are being repeated in the word mathematics. So we got 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 for the 11 factorial, and we got 2 times 1 for every 2 factorial times 2 times 1 times 2 times 1. So as you can see, we got to the same factors from the numerator to the denominator, which are the 2 factorial. So we can crash this one out. What will be left are this, from 11 down to 3. So if you get the product of this will give us 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 will give you 19,958,400 divided by 2 times 1 will give you 2 times 2 times 1 will give you 2, so 2 times 2 will give you 4. So what will be left? We would have 4,989,600 ways. Gets? Now let's have another example. This time it will be numbers. The number 5 questions at the back of your module wherein you are asked, let me see, how many distinguishable permutations can be made from the numbers 5 to 4, 5, 5, 4. So our formula for finding the permutation, distinguishable permutations for this one, again, still the same. P is equal to n factorial over P factorial, Q factorial, R factorial. Now try to look at these 3 letters at the bottom. It doesn't mean that since we got 3 letters here, down the n factorial, doesn't mean that you must have 3 here. So this PQR represents those numbers or letters that are being repeated in a set. So let's find first our n. N is straightforward. It is the total number of objects in our set, which are 6 digits. So our n is 6. So your n factorial would be 6 factorial. So this will be 6 factorial. And let's find out those repeated digits in a set. We got, what are those? 4. 4 are being repeated twice. Let's put it here, twice, because we need the frequency. What else? Number 5. 5 repeated thrice. So we'll put here the frequency because we will be using that one. Since we only got 2 numbers that are being repeated, which are the 4 and the 5. So our formula will be n factorial over p factorial q factorial. So we got our n, 6 factorial. Let's put it here. 6 factorial over your frequency for the number 4 digit is 2 factorial times 3 factorial for your 5. Expanding 6 factorial will give you 6 times 5 times 4 times 3 times 2 times 1 over this one. If let's expand 2 factorial, that's 2 times 1. And then 3 factorial is 3, 2, 1. Let's scratch this one out. 31. What will be left is 6, 5, 4. 6 times 5, 30 times 4, that's 120. And 2 divided by 2, so you would have 60 ways. Gets? Now let's have our last example. Our last example is finding the... Now let us proceed to the last formula, which is finding the permutations or of circular permutation. Circular permutation is the arrangement of objects, distinct objects in a set, in a circular table. Let's say, for example, I have here a circular tray. I got 4 appetizers and I would like to arrange 4 appetizers or 4 of its kind inside a circular tray. So the question is, how many possible arrangements that I can make with these 4 appetizers inside a circular tray? So the formula is pretty simple and straightforward. If we are solving for the permutations in a circular table with distinct objects, our formula is just P, circular permutation, we'll put as a sub C here, is equal to n minus 1 factorial. So you already know the fact that your n is the total number of objects in the set, which are 4 appetizers, so our n is 4. So applying it into the formula, you would have 4 minus 1 factorial. That will give you 4 times 3 factorial, or 3 times 2 times 1, which will give you 6. Alright, same thing if there are 7 of you who would like to sit on a round table. So you want to go to the party and you would like to know how many possible arrangements, seating arrangements that can be made when the 7 of you sit around the table. So we have 7 people. I will just name the initials of the 7 people in the form of letters A, B, C, D, E, F, G. So we got 7 people. You would like to sit on a round table and you would like to know how many possible arrangements that can be made. So same thing, our circular permutation formula is n minus 1 factorial. Your n is 7 because there are 7 people. N is equal to 7. So substituting with the formula, so we would have your circular permutation would be 7 minus 1 factorial. 7 minus 1 will be 6, then factorial, so that will be 6 times 5 times 4 times 3 is 2 times 1 will give you 6 times 5, 30 times 4, 120 times 3, 360 times 2 is 720 ways. Now, if there are some questions wherein you are being asked how many possible arrangements that can be, or seating arrangements that can be made when the 7 of you sit around the table, like 2 of you best friends, you would like to sit together. So for that particular question, we will talk about that one onto your on your MELT3 module, because that involves combination. Alright, so this will be all. Hello everyone, thank you so much for watching my short video lesson about solving for problems involving permutations. So let's just give you a summary of what we have tackled so far for this week's lesson for Mathematics 10 Quarter 3 MELT2 module, which are all about solving different problems that involves permutation. We have 4 formulas. The first one is permutation of objects taken all at a time. So for this type of formula, whatever the question that will be asked from you, wherein you are asked to use the same characters or objects in a set, like you are asked to arrange the letters in the word wisdom. So basically the question asks you to use all the letters from WISDOM. So you will just be arranging the position of the letters. So that requires you to use the first formula, which is pretty simple and straightforward, which is n factorial. So you already know the fact that your n is the total number of objects. So whatever your total number of objects, just get the factorial of it, then that's your answer. Now, for the second formula, we're in permutation of n objects taken r at a time. Now, for this type of question, it's just the same on our MELC 1 module, wherein we have used the formula for illustrating permutation. So, for this one, your r should not be greater than the total number of your objects. Like, for example, the 5 of you would like to have a photograph, but for every photo, you would like only to have 2 of you to appear in each photo. So, you would like to know how many couple of pictures you can take, considering all the possible arrangements that you can group yourselves into. So all you have to do is just determine your n, which is pretty obvious to 5 of you, so that your n is 5, and then deduct your r would be the number of people that would appear in a photo for each click, so that will be 2 based on my sample question. So your formula would be n factorial over n minus r factorial, which is so easy. Alright, and the third question is, kasan uta ginagamit ang permutation of objects which are distinguishable? So for the example that we had on the module, wherein you are asked to arrange the possible, or to arrange the letters in the word mathematics. In the word mathematics, there are 3 characters in it that are being repeated. So kung may repeated characters, repeated number, whether it's a form of letter or a number in a group, so that means you will be using the third formula, which are permutation or permutation of objects which are distinguishable. So the clue there is your n must be steady, so your n is the total number of objects still, while your denominator will be the product of the factorial of those frequency, kung kasan o nag-appear, I mean how many times nag-appear ang mga repeated letters and characters. Like sa mathematics, I have drawn m appeared twice, a appeared twice, and letter t appeared twice, so we got 2 for every letter. So that was our denominator, 2 factorial times 2 factorial times 2 factorial, until we have simplified our equation, then we got our answer. Alright, and the last one is permutation of objects arranged in a circular motion, like we call that circular permutation. But for this one, it's not complicated, because we are using the distinct objects. So if we have a combination in it, like 2 people would like to sit together around the table, if there are 5 of them, so that would require combination, which would be our next topic for the MELC 3 module, illustrating combinations. So I will define combinations there and illustrate how it looks like. It's just almost the same with permutations, just that there's additional characters on the formula. But going back to our last, or the fourth and the last formula, all you have to do there is just n minus 1 factorial. Nga may 1, it's because those objects, whether it's a people or elements, whatever those type of objects, they are seated or they were arranged around the table, wherein the table is circle. It can be rotated, so there's only one object or one element or one person in it, depending on the given, is on fixed position, and the rest are removable. So it's continuous. If you rotate it, you will be back on the same position. So that's why n minus 1 r factorial. So this will be all of my topic for the Mathematics 10 Quarter 3 MELC 2 module. I hope that you have enjoyed our lesson, and please answer our activities. And if you have some questions, don't hesitate to leave me a comment or message me. Thank you so much for watching, and have a great day. Stay safe and God bless. Bye.